Let's begin with a comparison between interior and exterior gateway protocols. Interior gateway protocols, or IGPs, are a category of protocols used within autonomous networks. Autonomous networks are networks that you control or that are under the control of a single organization. The most popular IGP protocols are OSPF, Open Shortest Path First, and RIP version 2. That's Routing Information Protocol version 2. Now there is a special mention here, and that's ISIS, which is Intermediate System to Intermediate System. ISIS is popular with extremely large autonomous networks, like an ISP's, or Internet Service Provider's, network. Exterior gateway protocols, on the other hand, are a category of protocols used between non-autonomous networks. So EGPs are used between networks that are controlled by different organizations or entities. The most popular EGP protocol is Border Gateway Protocol. Now, it's not uncommon for organizations to have more than one network that they are routing traffic between. These are called autonomous networks. Some IGP routing protocols use an administrator-defined Autonomous System Number, or AS number, as one means of identifying which networks can directly communicate with each other. The Autonomous System Number is not a metric, but a means of identifying a network that might possibly accept another network's traffic. Something to remember is that the AS is only significant within autonomous networks and has no relevance outside of them. Now let's move on to more routing concepts. Routing protocols can be classified by how they perform their routing. Interior gateway and EGP routing protocols can be broken out into three other categories of protocols, which is designated by their main method of determining routes between networks. The first class of routing protocols are distance vector routing protocols. With distant vector routing protocols, the routes are determined by how many routers exist between the source and the destination. The efficiency of the links in the selected route is not taken into consideration. With distance vector protocols, periodically the whole routing table is broadcast out onto the network. Then there are link state routing protocols. Metrics are used to determine the best possible route between destinations. Doesn't really matter how many hops there are. Once the route has been established, these protocols then only monitor the state of directly connected links and only make changes to their routing tables when changes to the links occur. With link state routing protocols, only changes in link status are broadcasted. And finally, there are hybrid routing protocols. These use aspects of both the distance vector and link state routing protocols. Let's talk about the next hop. The next hop is the next router in the path between 2 points. The next hop is often designated by an interface address of the device that is receiving the data, or by that router's name, or by that router's location. The routing table is the database table that is used by a router to determine the best possible route between 2 points. Different routing protocols use different algorithms to place routes in the routing table. The next concept is convergence. Convergence can be thought of as steady state. Convergence is measured in the amount of time that it takes all of the routers in an autonomous system to learn all of the possible routes within that system. Faster convergence times. Hello, I'm Brian Farrell, and welcome to PACE IT's session on basic elements of unified communications. Today I'm going to be talking about unified communications, and then I'm going to move on to some unified communication concepts, and then I'm going to end with voice over IP.